All right. Hello, everybody. To start, um, yeah, let's just rip the Band-Aid off. All right. So the news is that I'm leaving Flatiron School, and my last day will be next Friday, the 19th of November. Everyone on this call already knows, so that's great. But in terms of a transition, I have these notes for y'all. The instructor that will be taking over this cohort, his name is Abanit, and he will join one of our study groups, either tomorrow's study group or the first one next week. Just so you can meet him, he can meet you all. He is a great instructor. When I first started on this team, he was kind of like my mentor figure. So you all will be in very, very good hands. So what that means as well is on the 17th, that is your presentation day. So actually, let me pull up your calendar. So next week, on the Wednesday, we're doing our project presentations. So for those of you who present your project during that time, I will grade your presentation. And then I guess for the rest of the project review, and again, no pressure to do this because the deadline for passing this project is actually like December 3rd. If you want me to do your project review, you can schedule it for November 19th or before, and I can do the project review for you. But if it's after that, and if you still want to keep working on your project after November 19th, you will schedule your review with Ebony. And we have very, very similar project review styles. So it should be very, very seamless. And it's it's the same process pretty much. Okay. Any questions about that? Because I know that's like the most immediate thing that you guys are working on. Cool. And any like questions about that, feel free to let me know as well. Okay, so for the capstone phase, on the week of the 22nd to the 26th, that's Thanksgiving week. It also so happens to be the cohort break week. So I guess pros and cons of that. But anyways, there will be no study groups that week. If you want to do a one-on-one, I think you should be able to schedule one with Avani starting the 22nd of November. Did I say this already? I'll have him come to one of our study groups, either tomorrow's or next week, so that you all can meet him. Anyways, the week after that kicks off our 8-week capstone period. So with this 8-week capstone period, there will be a deadline of which you need to pitch your project. So you're going to pitch your project to Avneet. Some of you have actually already talked to me about your capstone ideas, and I've told you if it's okay or not. If it's okay, I would have already told Avneet about it. So you don't have to worry about like re-pitching your project. And plus this project pitch is not like a formal presentation or pitch or anything. You just have to let us know your idea. And then we'll just say okay or not. And then we might ask more like guiding questions on like, okay, what do you want to do with your project? What are the details? How do you plan on doing like, your machine learning, so on and so forth. So a few of you, I've already said that's a great capstone idea, do that. If you haven't yet, you have until, and I'll make these dates more clear, you have until the 10th of December to do your capstone idea pitch. So this first 2 weeks of the capstone phase, and actually before that, I know I'm going all over the place. On Thursday, the 18th, I'm going to do a capstone kickoff for you all. And then that's when I'll like really outline the capstone. I kind of just want you all to focus on phase 4, getting phase 4 out of the way first. But on that Thursday, I'll talk about more capstone details. But this part is important. The first 2 weeks of capstones, because Flatiron School starts cohorts every 6 weeks, you actually overlap by 2 weeks with the cohort that started before yours. And so for those first 2 weeks of capstones, you will be doing combined office hours with that cohort who is finishing up their capstones. And I think that will be a really, really good opportunity, one, to network and get to know other Flatiron students. I've actually met a couple students from that cohort. They're very, very nice. You can see their projects, see what are the things that they're working on. Maybe that'll help you come up with ideas if you're having trouble with that. And then there's just more people to bounce ideas off of. You just get to interact with more Flatiron students. That's always a good thing. So that's going to be very, very beneficial. And that will just be for the first 2 weeks of your capstone. Now there, I believe, no, actually, I'm not going to confirm yet. We're still working on the scheduling for what days the capstone office hours are going to be. Those two overlapping weeks might be different. Because you have to coordinate with another cohort, but they will be around the same time. So that will be that. Other thing is after the first 2 weeks, also I will double confirm with you all before I leave. But I think the capstone office hours should stay at the same days, same time. But I will double check because I have a lot of details in my head. But I will double check and confirm that with you all before the end of next week. Okay, so I talked about that, talked about project reviews. Any thoughts or questions while I try and remember if there's anything else I have to say? Cool. So with regards to the material that you will have from me, everything is on my GitHub. I'm not going to get rid of any of the repos, like any of the collab notebooks. They're going to still be there. Any of anything on GitHub will live on GitHub forever. My YouTube playlist is also going to stay there forever, so that's not going away too. I know that I had talked about doing capstone sessions on specific things like dashboarding, on creating a front end, doing a lot of these things. Now, every instructor does capstones a little bit different. And so while Abhinav does do these supplemental sessions as well on many, many different topics, I will still put my recordings of the capstone sessions that I usually do. I'll add them to our study group playlist, just so you have access to them, just in case you want to see what are the things that I talk about that may or may not be unique to the things that I talk about. Other than that, Abhinav, he does really, really good recap reviews of any of the topics that we went through throughout the program. Abhinav's also really good at neural networks and knows a lot about neural networks. So I think that would be great. And to just, see a different perspective on all of the material that we've been going through so far. So yeah, that is what the capstone will. I'll go into much more detail about capstones and all of that stuff next week. But any questions about that? Cool. Yeah, there's no easy way to tell you all that but cool. I think that's most of the things in terms of one-on-ones. Like I said, when I introduce Abhinav to you all, I'll also grab his one-on-one link so that you can start booking one-on-ones with him starting from the 22nd of November. We are also both on the East Coast. He actually lives just up the river from where I live. So same time zone as me, as I am. So and our work hours are the same. So whatever times you meet with them, whatever times you've been meeting with me, you can also meet with them. Cool. I think that's it in terms of the things that I have to let you all know about. Does anyone have anything that's still not sure about? Anything, questions, thoughts?
So for the capstone, it's the same format. It's like a non-technical presentation and also a project review. Is that?
That's correct. That's right. So yeah, in terms of deliverables for the capstones, exactly the same as all of our past projects. So yep, non-technical presentation, as well as a technical review.
Thank you.
You're welcome. Usually what I do, and what I know other instructors do that as well, is you're held to a slightly higher standard for the capstone, meaning that we'll be extra nitpicky on things like, hey, this code needs to be cleaned up, or maybe a definition is a little bit hand wavy. We'll be a lot more nitpicky with things like that. Cool. Anything else? Cool. Well, I'm going to send you all my contact info and how you can reach me after I leave. I am on the alumni Slack channel, which you will get access to after graduation, and you all are set to graduate in, I think, February. So yeah, you'll be able to find me there. If not, I'll send you all my LinkedIn. I actually am pretty active on LinkedIn messaging because I message a lot of former students over there. So you can still reach me. We'll definitely still stay in touch. Cool. So with that, let's get into office hours. So again, any of like your project specific questions, I'm going to stop the recording and talk about those then. But first I wanted to talk about some neural network stuff. So everyone working on the neural network project has had issues with input sizes for neural networks. So to talk about that, I have opened a couple labs. Let's see if I remember. Is this the lab that I wanted to talk about? Yeah, okay. So last week when I introduced, did I introduce the project last week? Yeah, that was last week, right? Okay, so last week when I introduced the project, one of the sequences that I said that I suggested that you all can use for this neural network project is start with a multi-layer perceptron that only has dense layers and then level up to a convolutional neural network. So this is a little bit confusing because these two neural networks, ones that are dense, purely dense networks and those that have 2D layers actually take in data differently. It takes in the same data, but in a different format. So first, and I think this is where, this is definitely the part where people get, I guess it is very, very confusing. So when you see here, we're using a densely connected network as a baseline. When you read in your data, you can see that it starts out as this shape. Let me zoom in. So this, it has I guess it is 4 dimensions, but this is basically 542 images, and each image is 64 by 64 by 3. Each image is a tensor. So this kind of data, your network can recognize this as a 2D image. And that's what's really powerful about convolutional neural networks. The fact that you can look at like patches of an image at a time with the kernel and the filters and all of those things. However, a dense network doesn't take in this data. A dense network only takes in data that is more similar to, you know, what we talked about before we got into 2D data, like pretty much like the shape of a data frame. So because of that, we have to reshape our data for the dense network only. And that's where this part comes in. So over here, you can see that they're reshaping each of the images. So let's just talk about trained images first. So originally we have 542 image with 64 by 64 by 3. So what does that mean? That means that each image is represented by 64 times 64 times 3 numbers. And that works out to 12,288. For proof, it is what, 64 times 64, times 64 times 3. Yeah, 12288. Where was I? There. Okay, so each image is represented by 12288 numbers. And so for a dense network to recognize our image data, it needs to see it as like one long vector. That's why we're doing the reshape specifically for any network that doesn't have 2D layers. This reshape, I know we've seen this a little bit, but I personally never really figured out what it was doing for the longest time. But here we have train images.shape 0, just because we know we have 542 images. So dot shape is this, 0 is taking this first number. So it's going to be 542 in this spot over here. And this -1 sort of coerces the rest of this 4-dimension array to meet like 542 rows, if that makes sense. So that's why you don't have to do the calculation of, okay, what's 64 times 64 by 3? I mean, you can 100% put dot reshape and then put 542 comma 12288 and it'll do just that. But if you don't want to do that calculation, that's what the -1 does. Sort of like the wildcard equivalent of using, yeah, just like saying wildcard for a number. So this shape of data is the one that goes into any dense network. So if you see here, this one is called train IMG, and then this other one is called train images. So IMG is the lengthened one. I think some people have been calling it unrow, and then images is the 4D, is the tensor data. So that's why when you see this one, when you have only dense layers, it is taking in train IMG. However, and I'm not sure if this lab even says so, when you get to your CNN, you can see that our first layer here is already a convolutional 2D image. And here we're setting our input shape to be 64 by 64 by 3, which is the shape of each image that we have. And so when we see here, what's being fit on is being fit on the trained images, the data that wasn't flattened out. So that is something it's something that you have to keep track of. You just have to keep track of which variable is the data in 2D, which is the data in 4D. And then once you have that set out, then just remember which variable goes into which kind of model, and you should be okay. Cool. Any questions about that? All right. So if you see an error that says like, I don't know, something about expected n dimensions equal to 2, but you gave n dimensions equal 4, that's what the error is. So also related is pre-trained networks. So pre-trained networks, we only talked about it for like 10 minutes. So I totally understand why it's like, it was a lot of information to take in. But for pre-trained networks, I'm going to go back to this notebook as an example. You can actually use whatever input shape you want for your image, for your pre-trained network. So you want the input shape of the pre-trained network to match the dimensions of your training images. So make sure that you're setting that to be right. And pre-trained networks should start with 2D layers if you're using like an image pre-trained network. So make sure that these dimensions match your input data. So I know this is really confusing the way that I set it up here, but there's also an include top parameter. And I put here, you want include top equal to false. So make sure that you're doing that. And the reason for that is if I do include top equal to true, if we look at this model summary, I mean, sure, you have all these convolutional blocks, but look over here, you have this prediction layer that actually predicts on 1,000 classes. And that's not what we're doing. The reason being is that this network was pre-trained on a bunch of data to just, identify, I guess, 1,000 different things. So because of that, that's why that is there. And whenever you have include top equal to true, you have these dense layers. Now, just by setting include top equals to false, you can see that this same VGG19 model with include top equals false, it ends at a max pooling 2D layer. So what's happening is we're just cutting off the bottom because these bottom dense layers are trained for whatever task this neural network was first set out to do. So because we're using this pre-trained network that could have been pre-trained on like random photos of like, I don't know, animals, terrain, other things, we want this network to work for our data. So we need to add our own layers so that it can, do the classification task that we need it to do. So in this example over here, and I set this to be called pre-trained. When I instantiate my model, I add all the pre-trained layers. It's also important that you freeze the CNN layers. Now, by freezing those layers, we're just setting whether they're trainable. We're setting that to be false because these are pre-trained. We don't need those to train anymore. As long as our subsequently added layers are being trained, it will do the task that we need it to do. You can sort of think of it as, okay, these layers are all about like detecting features. And then once we've detected all of these features of images, we feed that result into further layers. So after I add these pre-trained layers and set those to be trainable equal to false, I add my flatten layer. So it goes from 2D to 1D. And then I can add as many dense layers as I want afterwards. You can even add dropout if you'd like. Those are actually two main layers that you'd be working with, dense or dropout layers, and then you have your output layer as well. So you can see here in this output, you can see we have our VGG19 that is not trainable. We have our flatten and two dense layers that are trainable, so those parameters will be the only ones that will be adjusted in backpropagation. And then also we take a look at our complete CNN summary. We have 143 million parameters, but only out of that, 132,000 of those are being trained. So these 143,667,240, these parameters, our network would be a lot more efficient because those weights don't have to be changed. And we can just trust that those weights are a result of our model learning from whatever it was pre-trained on. Any questions about this?
What if, like, do we have to add those dense layers?
Yes.
Like, okay,
Yeah, because the dense layers will tell it what task it's doing, right? Because if you end it right at max pooling 2D, first of all, it's a 2D layer, and like your
Mhm.
model will just, it'll output in like a, it'll
so
output
still
a
have the
base.
structure of that other format. So okay. So
Yeah,
okay.
exactly. And in terms of these, like the structure of what you have after here, it, as long as it's like a bunch of dense layers, it can be anything. And what's most important is that like this final layer has to match whatever the task is. So if you have a binary problem, you want the dense with a softmax or sigmoid activation.
Okay.
So if you see back here in this predictions layer, it was like a 1,000 feature output. So that means this network will actually output like a vector length of 1,000, which is not what we want for our task. Like, how do we consolidate?
Yes.
Like, we have to compare this result to our like our actual like Y train, Y test data.
Okay.
Yeah.
Cool.
Awesome. Nice. Any other questions about this? You know, the input dimensions are, it's like, it's not even like how a neural network works. It's really just like, how do you use like a neural network? So I know it's a little bit confusing.
Yeah, I think I messed up when I with the input part. Like that was,
That's
I thought you had to match the neural network. I must
Hmm.
not been paying attention.
That's okay. There's so
yeah.
much. This day, I remember we talked about all of this stuff, right? We talked about doing grid search too. On that note, like when you're saving your model, don't forget that you have to not just save the model itself, but you also have to save its weights, because saving the model only saves like, oh, what layers do you have? But saving the weights actually saves the weights that were trained.
Cool. Yeah.
Awesome. I guess on that note, since we're talking about this, let's just say that you trained a model and you train it for like 100 epochs, and you save its weights, and you save the model as well. Let's just say in a different notebook, you want to further train the model on like maybe different data that has the same dimensions. If you load the model and load the weights, as long as you are not recompiling the model, and if you just do dot fit on the model, you can actually further train the data, further train the model on new data. So if anyone has done this, let's say you have this model dot fit in a different cell. If you run this once and run this maybe like 3 times, you can see that your accuracy or your loss will actually pick up from the end of the last time it trained. I know that English sentence didn't make sense, but y'all get what I'm saying? Yeah, the training will just continue as long as you don't recompile your model. So if you like, I don't know, run out of time and you want to like train it somewhere else or train it on like batches of data, if your computer cannot handle all of the data at once, maybe that's one use case. You can definitely do that. I've had one student like a couple years ago, wanted to train a model on a lot of data like on their hard drive, and so basically like cycled the model through like many subsets of the data. So that is something that you can do if you have like a lot of data, and that's one use case of saving the weights and then refitting the model. All right.
Question.
Mhm.
So like in regards to like data augmentation,
Yeah.
how important is it really to have like your train and test set have the same amount of images? Is it not important? Will it depend on case by case basis typically?
You mean like your train and test set having the same number of images?
Yeah, sorry.
All good, all good. It's not important. I think especially for your test set, like it technically doesn't really matter how many images you have in your test set. Data augmentation, it's interesting because like data augmentation can be used several ways. And by the way, data augmentation, you have this like, and this is from like the lab that you're trying to to classify whether an image is of Santa Claus or not Santa Claus. They basically take this image and like, I don't know, like make different variations of it. So you can see that it's like zooming in and like tilting it around just so it can recognize it in different orientations, or like you stretch it a little, you still wanted it to be able to identify. Data augmentation can be used to actually help with class imbalance. That's something, that's like one use case of it. But it can also be used to like, you know, literally things like this, to have your model understand different orientations of your data, or like different variations of your data. So I actually came across like an interesting, well, not came across, I had an interesting discussion with like some people about like data augmentation, should you use it or not? And one of the use cases that came up, or like one of the things that we were arguing / talking about is very similar to our project. When we have x-rays, right? And x-rays that are all of like chest x-rays, and they're all like very, very similarly taken. Like maybe like some of them have like a greater border around, maybe some of them are like, I don't know, zoomed in a little bit more than others. But how often do you get x-rays that are like tilted like 45 degrees, right? So you don't need, you technically, if you think that, yeah, I'll never get an input image that is like a chest x-ray, but like tilted like this, why give it to your model? It could confuse it. It could have it overfit to like that weird case, which honestly will not affect most unseen images, but you know, it's just unnecessary noise in your data set. So if you have something like a chest x-ray, think about how you would want to augment your data, right? Like augment it in ways that make sense for your model to learn. So maybe a little bit of stretching, maybe like a bit of like zooming in and out for like different sizes, maybe. I don't know anything about like what pneumonia is supposed to look like, or what are the things that doctors actually look for to diagnose pneumonia. I mean, for me, I just say, oh, it's a cloudy bit, so we needed to recognize whether that's that. So maybe like some stretching of the image. But yeah, to answer your question, data augmentation is not always necessary. Was that your question? I don't remember, but data augmentation is not always necessary, and you should use it in a way that that makes sense for your data.
Yeah, so in this data set, I mean, even though they're different like amounts, the pictures are all pretty standardized, so it's not really necessary. Okay, that makes sense.
All good, all good.
Thank you.
Yeah,
Guys.
you're welcome. I saw some projects where, yeah, like literally the case where like some people augmented the x-ray data and like flipped like your chest x-ray like upside down as an example. And there is a potential problem where, you know, some of the neurons will be like, oh, whenever I see an upside down chest x-ray, it must be like pneumonia or something like that, especially if you're doing your data augmentation unevenly across different classes. Which, you know, if you're trying to combat class imbalance, that is something that will happen. So you got to be very careful about how you're choosing to augment your data. Awesome. Cool. Any other like big general questions before I stop the recording and we can talk about our individual projects? All right, let me stop the recording right here then.